영상이 시작되기 전에 먼저 등장할 5개의 문장을 보여드릴게요. 빈칸에 들어갈 표현을 유추해보세요. 단어 하나하나를 직역하지 않고 전체 의미에 맞게 의역하고자 노력합니다. 그게 바로 영어식 사고의 출발이에요. 그럼 시작해볼까요?
It's how everything coordinates. It handles how all these different parts communicate. It's a complete overhaul. All of it gets synchronized and flows correctly. Blur the line between the cloud and the factory.
Welcome back to the magic of listening. We're here to provide key English resources, especially for those of you focused on business and economics.
That's right. And today we're continuing our journey into robotics. This is the second part of our 5-part series.
Okay, so last time we looked at the physical stuff, the components, right?
Yeah.
Chips, sensors, motors.
Exactly, the component layer. Today, we're moving up a level to the control and middleware layer. Think of it as the robot's nervous system. It's how everything coordinates.
The nervous system.
Yeah.
Okay, so if the hardware components are the muscles, this layer is more like the brainstem, telling the parts how to move together, the timing.
You got it. It receives signals, processes them, manages movement, and crucially, it handles how all these different parts communicate.
So let's dive into that control layer first.
Uh-huh.
What's the bedrock there?
Well, the foundation really is the robot operating system. You'll hear it called ROS.
ROS, okay.
And what's critical now, especially in the industry, is the big shift towards ROS2.
Right, ROS2. I've heard that's more than just like an update, isn't it? It seems quite significant for businesses using robotics.
Oh, absolutely. It's a complete overhaul, really. Big focus on security, which is huge now. Also scalability and much better real-time control.
And that standardization, it must make things easier for developers.
Massively. It means they can build really complex robots, much faster and probably cheaper too. Less time reinventing the wheel.
Who's behind this push?
Well, the Open Source Robotics Foundation, OSRF, they lead the core development. But you've got big players jumping in. Intrinsic, for example, part of Alphabet, now they're pushing ROS hard in industrial settings.
NVIDIA's involved too, aren't they? With Isaac ROS.
Yes, exactly. NVIDIA's Isaac ROS is really interesting. Combines ROS2 with their GPU power. That means you can bridge standard robot control with the heavy-duty processing needed for, say, complex AI or simulation.
So it connects the control layer to the smarter stuff we'll talk about later.
Pretty much. And you see the impact when major hardware companies like Mitsubishi Electric start releasing official ROS2 drivers for their own factory robots.
Ah, so they're opening up their previously closed systems.
That's the signal, yeah. It tells you that standardization isn't just nice to have anymore, it's becoming essential for industry. Open systems are winning.
Okay, so ROS2 gives us this flexible, standardized control. But factories, they're tough places, right? The nonstop work, heat, dust. What about when you absolutely need something to work reliably, safely, over and over?
Right, that's a different requirement. And that's where you find PLCs, programmable logic controllers. These are the real industrial workhorses.
PLCs, like the veterans of the factory floor.
Totally. They are designed purely for reliability and safety in harsh conditions. Think Siemens, Rockwell Automation, they're masters of this. They're like the super reliable traffic cop managing a specific critical intersection, ensuring no collisions.
And are they evolving? Or just staying the same reliable boxes?
Oh, they're evolving. Modern PLCs integrate things like edge computing. They can connect older, reliable machinery to the newer digital factory networks.
Okay, so PLCs handle the rugged, reliable tasks. But what if reliability isn't enough? What if you need like microsecond precision, maybe for surgery or a super fast drone?
Then you need something even more specialized. You move into the realm of real-time operating systems, or RTOS.
RTOS. What makes them real time?
It's about deterministic control. That means the system guarantees a response within a very specific, very tiny time frame. Microseconds, often. Think QNX or certain versions of Linux built for this.
So deterministic. It has to happen within that window.
Exactly. With an RTOS, missing a deadline isn't just a slowdown, it's a system failure. It's like a Formula One driver needing that perfect timing every single lap, no exceptions. Not just reliable, but predictably fast.
Okay, so we have components, we have ROS for general control, PLCs for rugged reliability, and RTOS for precision timing. But robots have eyes, sensors, navigation, lots of data flowing. How does it all talk together?
That's the job of the middleware. It's the layer between the hardware control and the higher level software, like the AI.
The translator.
Kind of, yeah. It acts as a universal translator and the main communication highway. It makes sure data from vision systems, motion controllers, navigation sensors, all of it gets synchronized and flows correctly, often at very high speeds.
And are there key players here too?
Definitely. A big name is Real-Time Innovations, RTI, with their Connext DDS framework. They specialize in that high-speed, super reliable data flow needed to coordinate everything.
DDS, Data Distribution Service.
That's the one. And what's really interesting now is how middleware is changing. It used to be sort of a separate thing you added on.
And now?
Now it's becoming integrated infrastructure. You see cloud providers like AWS and Microsoft Azure building these kinds of communication tools right into their bigger IoT and industrial platforms.
So coordination itself is becoming a basic utility almost, blurring the lines between the cloud and the factory.
Yeah, that's a good way to put it. Reliable coordination is just expected now.
Okay, let's wrap this section up. What's the big picture for our listeners? What does this control and middleware layer really do?
It's the crucial bridge. It takes the raw potential of the hardware, the motors, the sensors, and turns it into coordinated, predictable, useful action. It's where movement becomes controlled function.
And looking ahead?
Well, as robots get smarter and more connected, the demand for this kind of standardized, secure, real-time control software is just going to keep growing. It drives efficiency, lowers costs, improves safety. It's fundamental.
Right. That idea of moving from just hardware control to coordinated action sets us up perfectly for our next discussion, doesn't it? We'll be looking at the AI and software layer.
Exactly, where the real thinking happens.
But before we finish for today, here's something to think about. If we get this layer right, if safety, speed, and security become truly standardized across all industrial automation, what kinds of new business efficiencies can you imagine unlocking? Well, possibilities open up then. We'll explore that more next time.
영어와 시사경제 두 마리 토끼를 한 번에 잡는 알찬 시간 되셨다면 구독과 좋아요를 꾹 눌러주세요. 감사합니다.